Hi there and welcome to Lesson 57A. This is the very beginning of our scatterplots mini unit. The goal today is to introduce you to scatterplots, line of best fit, and correlation. First of all, let's answer the question, what is a scatterplot? Well, a scatterplot is a graph that relates two different sets of data. It displays them as a bunch of ordered pairs on a coordinate plane. A scatter plot could look like this. So here we see a bunch of points, but they tend to go in an upward positive direction. If you were to draw a line through the very center of the data, even though clearly the data is not linear, it would look something like this. That line would have a positive slope. Therefore, this would be showing a positive correlation or a positive relationship between the two things that are being displayed on the graph. You could also have a scatter plot that looks like this, where the points are falling. Even though, again, they're not linear, you could draw a line through the center of the data and it would have a negative slope. And this would be an example of a negative correlation or a negative relationship between what is being displayed on the graph. And then you could have a scatter plot that looks like this, where there's just points all over the place. And the two things that you'd be comparing on a scatter plot like this would have absolutely no relationship, and therefore there would be no correlation. Correlation just means relationship. So these are mainly the three different types of scatter plots that you're going to see when you are displaying two different sets of data on a coordinate plane. Let's take a look at correlation. Here in this example, we see a graph with beach visitors. We can see the temperature, we can see the number of visitors. It must be nice, nice sunny day. As you can see, the temperatures range from 80 to 96. Take a look at the table. Can you see in the table that as the average temperature increases, the number of visitors at the beach also increases? Well, that would make sense. Now, even though the scatter plot is not linear, we could draw a line through the center of the data. This line is called the line of best fit. It goes through the center of the points. Now, you can see that this has a positive slope, and that's because as the daily temperature increases, the number of visitors at the beach also increases. Both things being compared on this graph are increasing, and therefore you see that positive correlation or positive relationship. Let's take a look at this one. This is age versus video games. The age of people and how often or how many minutes they're playing video games. Now, if you take a look at the table, you can see as you draw your eyes down, as the age increases, the amount of playing video games decreases. And you can see from the scatter plot too. Of course, the points are scattered about, but they tend to fall. If I drew a line of best fit through the very center of the data, it would look like this. It's a line that's, obviously linear, and it goes right through all those points. We can see that there's a negative slope. Well, when you have a relationship like this, as one thing is increasing, the other is decreasing, causing the points to fall. So if you look at the x-axis, as the age increases, the amount spent playing video games decreases, giving you that negative slope. This is an example of a negative correlation. One thing's increasing while the other decreases. And lastly, here we are comparing age and the number of pets that people own. Notice that the points are scattered all over the place. You can be young and own a lot of pets. You can be old and own a lot of pets. You can be young and own no pets. You can be old and own no pets. It's just, is there really a relationship between number of pets owned and age? Not really. I could draw a line of best fit horizontally, or I could draw it vertically. I mean, there's really no positive or negative correlation whatsoever. So because there's no relationship between age and number of pets, we don't see an increase, we don't see a decrease. There's just no relationship. It's never the older you are, the more pets you own, or the younger you are, the more pets you own. So we would say that there's just no relationship. The points are scattered all over the place, and we cannot find a trend line. All right, so let's take a look at interpreting some scatter plots. Here I'm asking which scatter plot accurately represents the situation. We have the age and value of a vehicle. So you can see on the x-axis we have age, and on the y is value. So read across the x-axis. As the age of the vehicle increases, what should happen to the value? Does it increase? Does it decrease? Or is there no relationship whatsoever? Yeah, maybe you chose this one. Absolutely. Sure. As the age of a vehicle increases, the value will decrease. And so we see a negative correlation with this one. Unless it's a collector's vehicle, obviously. But it's a negative correlation because as one thing's going up, the other is coming down. And that would represent the age and value of a vehicle. Yep, the older they get, the less and less they're worth. Let's try this one. Which scatter plot accurately represents the situation here? The minutes you spend running and the calories that you burn. So look across on the x-axis at the time from left to right. As time increases, the more and more and more you run, what should happen to the calories you burn? Did you pick A? Absolutely. As the time you spend running increases, the calories you burn will also increase. And because both things that we're comparing are increasing, that is a positive correlation. This would be the best graph. All right, now I'm going to give you some scatter plots, and I want you to see if you can tell me if the scatter plot correctly represents the given situation. So for this one, this is showing the size of the dog and the amount of dog food purchased. This is showing a negative correlation. Is this correctly representing the situation? Yes or no? So look across the x-axis. As the size of the dog increases, this is showing that the amount of food you must buy should decrease. Is that the case? No, the bigger the dog, the more dog food you're going to have to buy. This should be a positive correlation, and it's not showing that. All right, let's try the next one. Number of tourists flying to Hawaii and the cost of plane tickets. This is showing a positive correlation, which means that as one increases, the other should also increase. Well, let's look at the x-axis. As the cost of plane tickets increase, the number of tourists wanting to fly to Hawaii increases. Does that make sense? No, this should be a negative correlation. As the cost of the plane tickets increase, the less and less and less people would be flying to Hawaii. They don't want to pay a lot of money. So this is not correctly representing the situation. Nope, this should be a negative correlation. All right, let's try this one. The number of people going swimming and the temperature. What type of correlation is being shown here? None. Is this accurate? Should there be no relationship between temperature and people going swimming? There should be a positive relationship. As the temperature goes up, the more and more and more people go swimming. So this is a no also. It shouldn't be a no correlation. There definitely should be a relationship going on here. Even though we're Minnesotans and we swim in the wintertime. Generally, when the temperature goes up, we swim more often. Okay, let's look at this one. Amount of clothing sold and the number of customers at a clothing store. So this is showing a positive correlation. That means as one thing goes up, the other goes up. So let's look at the x-axis. As the number of customers at a clothing store increases, the amount of clothing sold also increases. Would that make sense? The more customers, the more clothes you sell. Absolutely. This one would be a yes. This is the only one of the four that actually correctly represents the given situation as a positive correlation in this case. All right, now we're going to take a look at line of best fit. So here we have graphs that show the weights of dogs and the time it took them to complete an agility course. It's asking us which shows the line of best fit for the data. It looks like we have a positive correlation if you look at all four of the graphs. As the weight increases for the dog, the seconds it takes them to complete it, the agility course also increases. Just take a look at the lines. Which line of best fit would be most accurate? Well, being that they're all positive correlations, you should have a positive slope. So you should be looking at A, B, and C, right? But which one of those has a line of best fit that actually goes through the center of the points of the data, where there's about as many points above as there are below the line? Well, in that case, then the answer would have to be C. Of course, C is the best line of best fit. On this question, what does the y-intercept represent in the scatter plot? So here you can see that we are comparing the hours studied and test scores. So take a look at the y-intercept right there, 50. Come down on the graph. So 50 is the test score. And if I come down on the graph, the hours studied is 0. 0, 50 would be the point on the y-intercept. What does that mean? Take a look through the choices. Did you choose B? Yeah, if a student studies for 0 hours, 0 hours studied, we'd expect their score to be about 50. So here's just asking you to interpret a scatter plot. On this next one, which relationship is shown by this scatter plot? So here we're comparing the cost of a gym membership to the number of new gym memberships sold. So the cost and how many they're selling. Here it's showing a negative correlation. So that means as one thing goes up, the other comes down. Always read the x-axis first. As the cost of the gym membership goes up, the new gym membership sold goes down. That would make sense, right? The more that the gym memberships cost, the less and less and less people are going to want to buy them. So, being that's the case, and you see a negative correlation, as the cost goes up, the number sold goes down. Negative correlation should be doing the opposite. As one increases, the other decreases. Here we're asked which pair of variables would not fit the scatter plot. So here you can see a negative correlation. If I were to put age of a tadpole and length of their tail as the x and the y-axis, would it fit the scatter plot? So remember, with a negative correlation, as one thing increases, the other decreases. So let's look at A. As the age of the tadpole increases, would the length of their tail decrease? Yeah, the older they get, get a smaller tail and they become a frog. So that fits the scatter plot, right? So definitely we can't say that A does not fit the scatter plot. So we're going to mark A off because that would actually fit it. B, average temperature and the number of coats sold. So average temperature, as the average temperature increases, would the number of coats that you sell decrease? Yes, warmer it gets, less coats that are sold. C, the amount of clothes purchased and the amount of money left in a person's wallet. Would this fit the scatter plot or not? So as the amount of clothes that you purchase goes up, would the amount of money in your wallet go down? Yes, that would be a negative correlation. That leaves one left. Remember, we're looking for which one would not fit the scatter plot. A, B, and C would perfectly fit the scatter plot because all four of them would be showing a negative correlation. D, a person's height and their algebra grade. So as a person's height increases, their algebra grade would decrease if we put those two labels on this graph. Is that true? No, that would not fit the scatter plot. It would not be a negative correlation. What kind of correlation would it be? It would be no correlation, right? Aha, yes. All right, let's summarize. There are three types of correlations that a scatter plot can show. You have your positive, and that line of best fit will show the linear trend in the data. So even though the graphs are not linear, that you're always going to be able to tell that there's some sort of trend. So we've got the positive correlation, whereas one thing on the x-axis increases, the other thing on the y-axis also increases. Then you have the negative correlation, where whatever's on the x-axis increases, the y-axis will decrease. So as one goes up, the other comes down. And then you have the no correlation, where there's no relationship whatsoever at all on the graph. So those are your three types of correlations. Thank you for joining me for this lesson. You guys have a great day.